Hi, this is John. This is my Lab 15 of the TI-RSLK, the Robot System Learning Kit, road test that I'm doing for Element 14. And in this lab, what they have you doing is adding ADC. So they're using ADC14 from the MSP432, and then using the Sharp IR sensors. So I have placed the IR sensors onto the robot now. So they're placed here. There's 1, 2, 3. There's a ton of wires now. There's wires for the bump switches. There's wires for the IR sensors underneath. There's wires for the Sharp sensors. There's wires for this LCD up here as well. And one thing that was suggested, because these Sharp IR sensors are so noisy, is to add capacitors. So I have 3 capacitors up here. So I have the wires coming up, going to the capacitors, and I have power going to that. So those are capacitors between ground and power for each one of the IR sensors. And so that's adding some more stuff to that. So yeah, it's got a ton of stuff that's going on here. Oh, and there's wires for the encoders of the motors too, but that'll come later. With this, so you had to go through and part of the ADC, um, you had to include some extra stuff to this. So they have this ADC. Um, you had a program for the IR sensor, for the distance sensor, and for the ADC. And so they have this connected to 3 different ports on the bot. So there's 9091 and then 41 for the center one. And so this way they can you can have these triggered by an interrupt from the ADC, or actually from the IR sensor through the ADC, and then you read in the values. And then you have the ADC14 up here and have that configured, and it shows the different bits that are coming up here. So had to kind of figure out what channel it was on, and then the bits that were placed into it, and which one was connected. And you see this is for the different channels, 17, 12, and 16 coming in, and then you pass those values into the function, and then you calculate that. I'm not showing the actual code that I created, just so somebody else can do their own thing. A little bit of my main here. This isn't much. And so I have the main functions going in a loop. It's going through, and it's triggering these things periodically. So we got the init trigger for the ADC for the 3 different channels, and then we're passing in these values here. So passing them by reference so we can get the values that come back, and then they also have a low pass filter that's part of this as well. So it's passing into the low pass filters, and then it gets processed. So what happens is you can use the IR sensors in many different ways, and what you end up doing is you're calibrating this for the actual maze that there's going to be placed into. And so you have to get that calculated as far as where it sits, and then what's the best reference for that. But what I've done is I set this up to where it's kind of set on a generic distance right now. I haven't set it on to anything as far as the maze is concerned or anything like that. But there's also a serial output as well. So you get to see the serial output from the 3 different channels, and that's coming out as well. So you have the IR sensors coming here, and you also have serial out that's going for that too. So it keeps blinking. So what I have is the center one. If I place something in front of it, I have a piece of paper placed in front of it. It sets off the blue LED, which will indicate it's the center. And then the red is for the right, and then the green is over here on the left. And so when something gets in let's say if it's approaching something, and then it's going to trigger that, and then eventually it'll trigger the motors to spin. That isn't set up right now, but that'll come later. And same thing here. So this when something comes on the right, it should go left, and then when it comes over onto the left, it should go right. And then you can see the values on the serial interface as it changes too. So if I go over here, you see the one on the right is going down, and as you get closer, eventually you get to a point where it goes kind of the opposite way. And so if I pull back, and then it's going to go pretty much off. I'm kind of in front of it, so it's not going all the way to 800. I kind of have things in the way. So it should go to 800 to indicate that there's nothing in its way. Periodically it does. It's not calibrated completely, but it's close. and that's pretty much what you end up with on this particular lab. And it's introducing the Sharp IR sensors and ADC, reading those in, because they do come in analog and you have to convert that to digital, and then so you can read it and come out with values. And so you end up with these three different IR sensors that you can use to control this as it navigates through the maze, and that's what the end result is. And then the values you see out there, then you can have those set to control your motors and determine whether it's going to go right, left, and if it starts drifting maybe from the center, then you can have it adjust, and then also adjust the speed as well, I guess, as it gets down further. But that's pretty much what that is. It's an ADC, and it's got that. Now we have IR sensors. Now we got to start tying all this together. And there's a few more labs. So this is it's getting close. So there you go.